Okay, so today in this next bit we're looking at, as it says here, motion with constant acceleration. So acceleration stays the same throughout the whole motion. So in the previous bit we looked at somewhere the acceleration, you may have an expression for it in terms of t, and it may change, but today we're looking at it where it's just there is no change, so it stays the same throughout the motion. And there's four mathematical formula that we can use for motion in a straight line with constant acceleration, and there will be proofs of these in your textbook should you choose to look at them. All right, so v equals u plus at, s equals ut plus a half at squared, v squared equals u squared plus 2as, and two versions of this one where s is u plus v on 2 times t, or that version of it there. So what do all these symbols mean? So S, sometimes you see it as X, is our position. U is our initial velocity, speed. V is our final velocity. A, of course, is acceleration. I can't spell, so like another C in there. And T, of course, is time. All right. 2, 3, 4, 5 variables there. And there's 4 equations. Now, there is another equation if you rearrange this to find u and then substitute it in there. S equals vt minus a half at squared is another one that you can look at if you so desire. And so what we've got here then is we've got 5 variables, 5 equations, and so in the questions we would have 4 variables, so we choose the version or the constant acceleration formula that's appropriate to the question given the information. All right, so you make that selection based on the information you've got and what you want to find out. So let's look at some examples. So let's look at this one here. So it says a body is moving with uniform acceleration. In the 3rd second of its motion, it covers 30 meters. In the 7th second, it covers 18 meters. Find the acceleration and initial velocity. Okay, so we need to figure out, or I need to explain what it means by the 3rd second, the 7th second. So what does it mean? So time goes like this. We start at 0, then 1 second, 2 seconds, later 3 seconds after we start, 4, 5, 6, 7, and so on. We might go to 8 after that. So that's how time goes. Now, this bit, the 3rd second, the 7th second. So let's have a look at. So here to there, that's the 1st second of the motion. Here to there is the 2nd second of the motion. Here is the 3rd, then the 4th, then the 5th, the 6th, the 7th, and then if we needed it, the 8th. All right, so the 3rd second is t equals 2 through to t equals 3. Now, with these formula that we've looked at up here, All right, they all relate to time being measured from the start. All right, so we can't just put for this t equals 1 and say that it's 30. What we need to actually do is we need to say that the distance travelled in the third second is the distance it travels in 3 minus the distance it travels in 2. All right, so that's the distance it travels in 3 seconds. The distance in the first 3 seconds, the distance it's travelled in the 2 seconds. So this distance there is the distance it travels in the third second. All right, so if I do that, S3 minus S2 is equal to 30 metres. That's what it says, yes. The third second of its motion, it covers 30 metres. And so a similar discussion about the 7th second, that's this second here. So again, from the start, let me just change my colour. So from the start, we're looking at the distance it travels in 7 and the distance it travels in 6, and in the 7th second, the 18 metres, that's what it travels in that second there. So again, we've got to do the same kind of thing. Distance travelled, not after 2, the distance travelled in 7 seconds minus the distance travelled in 6 seconds is equal to that 18 metres that it travelled between t equals 6 and t equals 7. All right. So then what we've got is we've got a whole bunch of stuff here. So let's have a look. We want to know, excuse me, we want to know acceleration and initial velocity. All right, so maybe I'll change my pen back colour. So what we want to know is we want to know what's acceleration, initial velocity, what's u. What have we got? Well, we've got time and we've got these distances. So we've got time and s versions of it anyway. So we want to use the formula that it uses those 4 things. And the formula that uses those 4 things, when you look at up here, there it is, it's that one. So let's go down here again. And so we're going to use S equals ut plus a half at squared. So what we've got to do here, we need S3 minus S2. So let me just write that there, S3 minus S2, and that equals 30. And S3, and I'll put it in a bracket, is u times 3 plus a half times a times 3 squared. And S2, when we subtract, that's u times 2 plus a half times a times 2 squared. And when we do that subtraction, we get 30. All right. So if I was to, let me put all this together. So we've got 3u here plus 9 over 2a, and then we're going to take away 2u, and we're going to take away 2 squared is 4, half of 4 is 2a, and that's 30. All right, and so we then get u plus, well, 2 of course is 4 over 2, so we got 9 minus 4, which would be 5, over 2a, and that's 30. Now, if we do the similar thing here for S7 minus S6, and that's 18, again putting 7 and 6 in there, and I'm going to be, excuse me, I'm going to be a bit lazy here and not do all of that. But what you do get to is you get to u plus 6a is equal to 18, and so now we've got two equations, and we need to solve them simultaneously. All right, and again, in the interests of time, and one I've prepared earlier, when you do that, you get that the acceleration is equal to -3 meters per second squared, and the initial velocity will be 37.5 meters per second. All right, so that's what you end up with that, solving simultaneously. All right, okay, so there's one example. Another example that we're going to use is vertical motion. We can use vertical motion under gravity, because the acceleration due to gravity is constant, and it has a value of 9.8 meters per second squared. And again, and I mentioned this in the previous one, is that I always would assign upwards direction as being positive. So if the upwards direction is positive, then gravity is trying to pull it down, so the acceleration has a negative direction, so the acceleration is down. All right, I always stick with that, and as I said before, so therefore I don't confuse myself with each question as to what I think. So, of course, in the exam, it says the acceleration due to gravity is 9.8, but in the exam, if you're not directed to give your answer to a certain number of decimal places, then you just use the symbol G, the acceleration due to gravity. All right, so unless they tell you, I want the answer in a certain number of decimal places, in which case, if they do that, then you'll use the value of 9.8. But if they don't tell you to do that, use G. All right, and the first question on the 2020 exam one, was it just exactly that? You had to use G and not 9.8. All right, anyway, I'm starting to waffle on. So vertical motion, it's constant acceleration, so we can use one of those formulas. All right, so here's an example. I'll just have a little drink first. All right, so a ball is projected vertically upwards with a velocity of 56 meters per second. Find A, the time taken to reach the maximum height, and B, the maximum height. So it's things that we know straight away. I'm already taken up as being positive. So I know that my initial velocity is 56, and that's up. I know, because it's gravity, that the acceleration is negative 9.8. Now this here, time taken to reach maximum height. So for part A, not only do I know these things, it talks about maximum height. Now remember, in the last video I talked about maximum height, and so at maximum height we know that V equals 0. So we know V equals 0. And it asks for time. So time is the thing we're after. So we've got U, we've got V, we've got A, and we want T. So we go up and we select the one of those that has those four things in it, and you see that it's v equals u plus at. All right, so let's put in that information. So our final is 0, stops momentarily, 56 plus negative 9.8t. So 0 equals 56 minus 9.8t. Add 9.8t, put to both sides, equals 56. Then divide by 9.8, and when you do that, you find that the time is 5.71 seconds. All right. And then the next part, just looking at my notes here, the next part we want to know the maximum height. Now, it is possible, in this case, it is possible to use, so v equals 0, we know, u equals 56, we know, a equals negative 9.8, we know, and the time, we've just figured that out to be 5.71, and we want to know the distance, so we want to know s. So really, in this time, we can actually use anything, because we've got 4 of the 5, and we want the other one. So we can use anything. We need to clarify that. Can't use this one because it hasn't got s in it. We can use anything with s in it. All right. Now, what I like to do, where I can, is not use something I've just calculated in case I've made a mistake. So there is one of the equations that has v, u, a, and s in it, and that's the one that's v squared equals u squared plus 2as. So I would prefer to use that rather than something with time in it, just in case I've made a mistake here. All right, so put in the information. So 0 equals 56 squared, which is 56 squared. I haven't written that down. Oh, have I? Yes, I have. 3136, I believe. Minus 19.6 s. Add 19.6 s to both sides. Then divide by 19.6, and you get that it's 160 meters is how high it is. All right, so someone's got a pretty good arm on them to be able to throw it at that speed to that height. All right, so that's constant acceleration formula. So if you do physics, you've already had a fair bit of exposure to these. If not, you have to persist with it. Get help if you get stuck with stuff and you're not sure what to do. And as always, have fun.